about deductive reasoning. And remember we talked about inductive reasoning last week. Inductive reasoning is a conclusion based on a pattern of events. No real logic involved there. Deductive reasoning is a process of reasoning using given and previously known facts to reach a logical conclusion. And there are two laws that we're going to talk about in deductive reasoning. It is the law of detachment and it is the law of syllogism. Those are kind of weird words. That we're going to talk about both of those. And the law of detachment is the law of logic that states if a conditional statement and its hypothesis are true, then the conclusion is also true. So what happens in the law of detachment is if you have an if statement, if, P, and Q, and then you make a second statement that references the hypothesis P, and then you can make a more specific question referencing the conclusion. Okay, and that is the law of detachment. For example, if Alicia scores 85 or greater on her test, she will earn an A as her final grade. Alicia scores 89 on her test. What can you logically conclude? That she will earn an A as her final grade. That is correct. Okay, so we have a statement P, and then we have an P and Q right there. Okay, then we make a second statement that references the hypothesis, the P. And so then we can make a statement referencing the conclusion, the Q. Okay, and we would say that Alicia will earn an A as her final grade.
Wait, what does that say about the 80?
That's just the P about the 89. Yeah, I'm just saying, okay, this is a statement P and then a statement Q. Then you make a more specific statement referencing the P, and then you can make a more specific statement referencing the Q. Okay, here's another one. If two angles are congruent, then the measures of the two angles are equal to each other. Angle 1 is congruent to angle 2. What can you logically conclude about the measure of angle 1 and 2? So again, we have our if P, two angles are congruent, then the measures are equal to each other. Okay, that's my if P and Q. Then I'm going to say, okay, more specifically, angle 1 is congruent to angle 2. What can I say about their measures? That they're equal to each other. So my Q would be the measure of angle 1 equals the measure of angle 2. Alright. If you finish the race in under 30 minutes, then you win a prize. You finish the race in 26 minutes. What can you logically conclude?
You're good.
Then you win a prize, right? Okay. Alright, so this is my FP, then Q, right? You finish the race in under 30 minutes, you win a prize. Then I'm more specific. Okay, Dalton finished the race in 26 minutes. Okay, I can conclude that Dalton wins a prize. Okay, now, what if instead of this statement right here, I put Dalton wins a prize? What could I logically conclude? Do what? Don't you know?
What?
If I said, if you finish the race in under 30 minutes, you win a prize. Dalton wins a prize. Can I say that Dalton finished the race in under 30 minutes? What if he got a prize for a game he played? Okay? When you're using the law of detachment, you have made a statement if P and Q. Okay? Your second statement has to reference the hypothesis. This one references the conclusion. And you can't use the conclusion to prove the hypothesis. Okay? Just because he wins a prize, it doesn't mean the prize has to be for finishing the race under 30 minutes. Okay? He might have got a participation prize because he just finished the race. Yes? right? Okay. Well, but it says if you finish the race under 30 minutes, you win a prize.
Right.
It doesn't say you win a prize if you do the other. That's not necessarily true. Okay. All right. We'll talk about this a little bit more. I think it'll start to make sense here. All right. So that's the law of detachment. Again, you make an if statement. The second statement has to reference the if. The third statement has to reference the then, and not the other way around.
So what?
Okay.
You conclude that
Well, in this one right here, it would be no valid conclusion. You couldn't conclude anything. I'm sorry, I should have written that down. Okay, there would be no valid conclusion if that was the second statement. Okay. All right. The next one is the law of syllogism. Okay, and in this law, you have two conditionals, and the conclusion of the first one is the hypothesis of the second one. So, for example, you have if P then Q, then I repeat my Q as my new hypothesis and marry it up with the third thing. So, if P then Q, repeat, if Q then R, then I can put if P then R. Okay? For example, Kenji plays the instrument. If Kenji plays the instrument, then he plays a brass instrument. If Kenji plays the trumpet, then he plays the brass instrument. If he plays the brass instrument, he is a member of the marching band. So we have if P, then Q. Okay, there's my first statement. If P, then Q. Then I repeat my Q. If he plays the instrument, then he is a member of the marching band. So the law of syllogism allows us to take the first hypothesis with the second conclusion. So what would that be? What? If Kenji plays the trumpet, then he's in the marching band. Okay, here's another example. If you call the fire department, then the fire truck comes. If the fire truck comes, then they put out the fire. If you call the fire department, then they come out and put out the fire. Okay? Do you see how I take the first one? The middle thing drops out, that's common, and then you hook it up with the third thing, right? Okay? If you are hungry, you eat a sandwich. If you eat a sandwich, then you are happy. If you are hungry, then you are happy. Okay? I mean, that's kind of a weird one. But anyway, it takes two conditionals and marries them together for a third one. And the middle thing that repeats is what drops out. Okay? Let's try another one. If points A, B, and C are collinear, and B is between A and C, then ray BA and BC are opposite rays. If ray BA and BC are opposite rays, then AB plus BC equals AC. What can you conclude? And B is between A and C. Then AB plus BC equals AC. So this is my if P, then Q, then I repeat, if Q, then R, and so then I put P and R together. If points A, B, and C are collinear, and B is between A and C, then AB plus BC equals AC. So that thing in the middle drops out. Okay.
Wait. What is above the little, wait, is that R?
R right here?
Yeah.
Yes.
don't really understand it because just because he plays the trumpet does not mean that he's in the band.
True. I mean, ultimately, yes. But I'm just trying to show you how the law of syllogism works, right? Just like the one I did, that if you're hungry, then you're happy. Well, not really. Probably if you're hungry, you're more hangry than happy, right? But that's just the way the logic works. Okay. And I'm going to show you after the lesson, they use law of syllogism in commercials all the time. There's one with DirecTV, they use it all the time. So I'll show you kind of how you can really go overboard with it. Okay. Here's another one. If an integer is divisible by 6, then it is divisible by 2. If an integer is divisible by 2, then it is an even number. So what would your conclusion be? If an integer is divisible by 6, then it is an even number. Good. Okay. So if an integer is divisible by 6, then it is an even number. So again, you have if P, then Q, if Q, then R, and then this is my if P, then R. Alright, now this one, the way it's written is really strange. It kind of threw me when I first looked at it. If it is a holiday, then you don't have to go to school. If it is Labor Day, then it is a holiday. Now, if you look at the sentences in the order that they're written, it doesn't really have a logical conclusion, okay? But if you just take it to fact, the two statements, they can't be put together if they're written in the opposite order. So, like this right here doesn't marry up with Labor Day, right? But if I looked at this is my P and this is my Q, if P and Q, and then see how they repeat, it is a holiday, if Q, then R, then it would marry together. Yes? You see how it would work that way? Okay. So if it is Labor Day, then it is a holiday. If it is holiday, then you don't have to go to school. So then what would be my if P, then R? Right. If it's Labor Day, then you don't have to go to school. Okay, now, what if I did this? What if I said, let me get this for you. If Dalton, no wait,
David plays basketball.
David plays basketball. I'll just say because I already used Dalton in my other example. Okay, so if you are an athlete, then you play basketball. David is an athlete if you are an athlete, then you play football. Okay? Now, if I wrote something like that, would there be any logical conclusion? Does it follow the law of detachment of the law of syllogism? No. It repeats the hypothesis, but it marries it up with two different conclusions, right? So there would be no logical conclusion there. Now, if I change this, and that would be your answer, no logical conclusion. If I change this to David is an athlete when, or if David is an athlete, then David plays basketball. Could you conclude that?
Yes.
Yes. What law would that be? What law would that be? If you're an athlete and you play basketball, if David is an athlete and David plays basketball, which one's that one? What?
It's the ones that we do like the attachment.
It's a detachment one, right? Because you have a generic if-case statement, and then we reference the hypothesis and conclude the conclusion. Okay? All right? So, some of the questions will be kind of weird. There is no logical conclusion. Okay? So make sure that you're going back and looking at those rules and make sure they follow. All right. In this last one, or no, there's two more. If you're climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level on Earth. If you're on the tallest mountain above sea level on Earth, then you are on Mount Everest. Okay, so there's my two statements. Now, I'm going to say you're climbing a mountain at an altitude of 29,000 feet. What could I conclude using the law of detachment?
If you're an altitude of 8,500 feet.
Then you're on the tallest mountain on sea level on Earth. Okay? That's what I would conclude with the law of detachment. You are on the tallest mountain above sea level on Earth. That's just using this statement right here, okay? Because that's all I can do with the law of detachment, okay? Because it says, okay, you're at an altitude of 29,000 feet, then you are on the tallest mountain of sea level on Earth. That's using the law of detachment. What would I conclude if it was the law of syllogism? I'm just telling you that you're climbing a mountain of altitude of 29,000 feet.
You're on the highest mountain.
Then you're on Mount Everest, right? Because you can conclude them both together. Okay? In that case, we have our if P, then Q, if Q, then R, so we can do our if P, then R, right? Okay? Now, let's say I didn't ask you to use either. What would be ultimate your conclusion if you read all of that?
We're fine. No.
Which one of these laws would be the most conclusive given all of that information? Detachment. Why not the syllogism? You're on Mount Everest, right? Because it says if you're climbing at a mountain at an altitude of 28,500 feet or higher, then you're on the tallest mountain above sea level. If you're on the tallest mountain above sea level, you're on Mount Everest. So I'm telling you, you're climbing at an altitude of 29,000 feet, right? I can conclude I'm on Mount Everest. Okay? So this would be your ultimate conclusion right here. It would be that you're on Mount Everest. Okay? But these both can be concluded due to different laws. Alright? Okay, last one. If you're speeding, then you get a ticket. George gets a ticket.
If you're speeding, you get to.
Well, no, because tickets everywhere.
Now David's thinking out of the box here, right? Okay, you have to think, does this make sense? This is like if P and Q, right? Okay? If you're speeding, then you get a ticket. Well, George gets a ticket. But it doesn't necessarily mean George was speeding. Okay? He could be not wearing a seatbelt. He could be running a red light. A lot of different things could happen. Alright? The problem here is this statement references the conclusion. And you can't use the conclusion to prove the hypothesis. Alright? So in this case, there would be no valid conclusion. No valid conclusion. Alright, so remember, the law of attachment have pre-if ends. You have if P then Q, repeat, if Q then R, and then marry up P and R.